Parabolic motion refers to the motion of an object that is thrown or projected into the air at an angle. Parabolic motion is a combination of horizontal motion with constant horizontal velocity and vertical motion with a constant downward acceleration due to gravity. The vertical motion of a project object is independent of its horizontal motion. One common variable between the horizontal and vertical motions is time.
Horizontal motion is a motion of a ball rolling freely along the level surface. Horizontal velocity is always constant. Vertical motion, motion of a free-falling object, force due to gravity. Vertical component of velocity change with time. Parabolic motion, path traced by an object accelerating only in the vertical direction while moving at constant horizontal velocity.
Okay, now we are going to explain this problem. Okay, for this problem we know that the initial velocity is 45.74 meters per second and its elevation angle is 59 degrees. With this information we can know that the vector in x is 23.56 and the vector in y is 39.21. We also know that the velocity in x is like uniform linear motion. So knowing this, we know that the vector in x is always the same, so it's 23.56. That is for the seconds 0 to 8 from the begin to the end. Okay, now to obtain the vectors in y, we have to subtract 9.8, that is the value of the gravity of the vector of y of the previous second. For example, in the second 0 we have 39.21 meters per second. So in the second one, from the value of the vector in y in the second 0, we subtract 9.8, and the result of that operation is 29.41. We continue doing that till the second 4. Now if we continue doing this, we're gonna notice that we have the exactly same values but negative. Okay, to obtain the horizontal vector we have to use the formula to horizontal vector. The formula that we used to use is vector in x to the square plus vector in y to the square. All of that we get the square root, and that is the horizontal vector. We do it with all seconds and we have the horizontal vector in the second one is 37.68, in the second 2 is 30.65, in the second 3 is 25.62, in the second 4 is 23.56. But in the second 5 we notice that we are having the same horizontal vector than in the second 3. In the second 6 we have the same horizontal vector than in the second 2, and so on. Now we have to obtain the angle of the horizontal vector. To do that we need to use the formula inverse tangent of vector in y over vector in x. We continue doing it till we notice that in the second 5 we have the same number that in the second 3, but it's negative. These phenomena happen also in the second 6, 7, 8, and so on. Okay, now to obtain the range, initially we know that the range in x is 0, always. So what we did is to multiply the vector in x, that is 23.56 times 1, and we obtain the range in the second one. Then to obtain the range in the second two, we multiply 23.63 times 2, and to obtain the range in the second tree, we continue doing it, multiplying the vector in x times the time you want to obtain. Okay, after that, finally we have to obtain the height. We know that at the beginning, in the second zero, the height is equal to 0. Also, the height is equal to 0 when the parabolic throw ends. It also means that in the second 8 we have 0. Now, to obtain the height, or the value of y per second, we're going to use the following formula. Y is equal to initial velocity in y times time plus the gravity times the time to the square over 2. We substitute the values. For example, in the second one, the initial velocity is always going to be the initial velocity for y in the second zero, that is 39.21, times the time that we're going to obtain the value of y for the first second, so we use 1, plus the gravity, that is minus 9.8, times the time, that is 1 to the square, that's over 2. After that, we obtain that the height at the second one is of 34.31. We're still doing it for the rest of the 8 seconds, but only like changing the value of the second. And for the second 2, we have that it's 58.32. For the second 3 is 73.53. Then at the middle point, the highest height in this parabola is 78.44. After that, it starts like decreasing the height, and we notice that in the second 5 the height is the same that in the second 3. The second 6 the height is equal in the second 2, and so on. Now we already finished the problem. As we see during the explanation, it's very simple to do, and if you know the formulas, it would be really easy to calculate these things. To do this problem, we based on the video that you've seen before, that it's a partner hitting a football ball, yes, and we calculate all this thing only by knowing the horizontal vector and the angle in the second one. Thanks for watching.